Okay, today's lecture will be bipolar junction transistor, that is BJT. That is the transistor we have seen earlier. And the BJTs are actually divided into two parts or two types. One is NPN transistor and another one is PNP transistor. Normally 99% of the cases we will be using NPN transistor. PNP transistors are very rare. And what is the history? In 1947, three scientists, William Shockley, who is seated here, John Burdeen, who is at the left, and Walter Brattain at the right, they actually made the transistor in 1947. Okay, that time the transistor was a huge one. That means with different parts and a very huge one. But day by day, it became smaller, smaller, smaller. That transistor was made of different type of materials because the single crystal germanium was created in 1952 and single crystal silicon was created in 1954. So you can actually go for the history, you can hear. But remember, 1947 is the day when transistor was created and history was changed. Now, transistor construction. So here always you have to remember, transistors are actually sandwich of PNP material or NPN material. Normally the middle part is smaller and the bigger, the other two parts are actually bigger. So middle part is always called base, other two parts are called emitter and collector. The middle part is base, other two parts are emitter and collector. Can you see that E and C? Emitter and collector. This is the base, this is emitter, this is collector. Okay. Base to emitter. Base to emitter current is for majority carriers. Base to collector current is for minority carriers. That's why almost there is no current that flows from base to collector. Okay, base to collector, no current almost for P-type material. Now, so remember, we will be using NPN transistor for most part. Here, yesterday I have shown you a video, right? In that video I have seen, if we give a current flow, this is PNP transistor, and I want to show you the NPN. Okay, here. If we give a current to base to emitter, if we give a small current here, a small current. Okay, if I give a small current here, what happened? This small current actually allows a big current to flow, right? Here you can see this current is IB, that means the base current. That means this current goes from here to here. Okay? This current, however, is a big current. This is called IC. And these two mix together and become IE. This current is called IB, whatever that is going up. This current is called IC. And this current is called IE. This IB plus IC, IB and IC, they mix together and become IE. So what happened? Your IE is equal to IC plus IB. Okay? Got my point? Okay. Now here, one thing you have to understand, your IC is big. Your IE is also big because IC is mixed with IB and become IE. So these two are big. But this one, however, IB, this is very small. This current is very small. Okay? So can we call these a very small current? Of course. So from here, can we call IE equal IC? Almost equal. Can we call them? Why? Because let's say you have 100 taka. If I give you one more taka, how much money you have? To be precise, you have 101 taka, right? But practically, you have 100 taka because that 1 taka is nothing. because you cannot get anything by that 1 taka, can you? So here IB is equal to 1, IC is equal to 100. So your addition is 101, but can you call this 101 equal to 100? Of course we can, because 101 and 100, they are actually equal. Okay. Now there are many configurations by which you can connect your transistor. One configuration is common base configuration. Common base means this is a common base configuration. Here, the base is common. Okay? And this is the input and driving characteristics for common base configuration. This was the characteristics from silicon diode, you can see it. This is the output or collector. This is the input or driving characteristics. This is the output characteristics. Here you have IC, here you have VCV, because common base, collector, common base, that means collector to base voltage, and these are actually your IE. Okay. Next one will be, oh, by the way, here they said IC is almost equal to IE. You can call it, no problem. And VBE is VBE, always 0.7. Okay, understood? VBE is 0.7. Now come here. What is alpha? DC mode. In DC mode, the level of IC and IE due to the majority carriers are related by a quantity is called alpha. So the what is that? The ratio of IC and IE, that is called alpha. Since both of them are almost equal, so which one is bigger? IE is bigger or IC is bigger? Hello? IC?
IC, sir.
No. IC plus IB.
Oh.
That is equal to IE, right? So which one is bigger? IE is slightly bigger, slightly. Okay? IE is slightly bigger. So can we call, this one is smaller, this one is bigger. So can we call alpha is a bit less than 1? Can you call it? Because the upper one is smaller. But in practical life, they should be almost equal. Equal to 1, right? Almost. If they are equal, almost equal, we can call it alpha is equal to 1. Can you call it? Yes, we can call it in practical, in theory. But in practical devices, alphas are typically from 0.98 to 0.998. Okay? Remember this value. Alpha is practically 0.90 to 0.998. Remember? Can you remember it?
Yes, sir.
Okay. Now, with most values approaching the higher the end of the range. Okay. No, you don't have to remember that. So alpha is the ratio of IC and IE. Okay. Now come here. Now, next configuration will be common emitter configuration. This is the configuration we use most of the time. This is the configuration we use 99% of the time for NPN and for PNP. Okay, this is the common emitter. That means that your emitter is common in both circuits. Previously, your base was common in both circuits. Now your emitter is common. Here, in this circuit, in this part, your emitter is here. In this part, your emitter is here. That's why it's called common emitter configuration. What will happen here? Your IB will go to the emitter, along with your IC will go to the emitter. So what is happening here? This current is going like this. This current is going like this. So this is called IC, this is called IB, and both of them mixed together become called IE. Okay? This is called common emitter configuration. This is the configuration we use most of the time. And this is the symbol of your transistor. Which one? This one. This is the base. This is the collector. This is the emitter. Okay? Base, collector, emitter. By the way, this is NPN transistor. NPN transistor. Which one will be the PNP? Same. But this time arrow is not like that. Arrow will be like this. Again, this is collector, this is emitter, this is base. This is the PNP transistor. Understand? Symbol. Here, you can see it. Now, this is the common emitter. Common emitter configuration, output characteristics. So today we will be making these output characteristics on computer. Okay? That will be today's lesson. But before that, I want you to see these. Beta, yes, this one. Beta. Beta is the ratio of IC and IB. Beta is the ratio of IC and IB because this is the gain factor. This is the gain factor of your transistor. Normally, the value of IC is much bigger than IB, right? We know it. The value of IC is much bigger than IB. So this value should be bigger than 1, right? Obviously, because if it is much bigger, if it is smaller, this value is greater than 1. So normally the values are from 50 to 400. Beta typically ranges from 50 to 400, but remember, if it is not given, you can consider it is 100. If it is not given in your question, you consider it is 100. So what do you mean by that? Remember, if the value of beta is 100, that means your IB is multiplied by 100. So if your IB is small, let's say 2 milliampere. Oh. If it is 2 milliampere, so your IC will be 200 milliampere because that is multiplied by beta. Okay? Always remember. Okay. Now you will be making the graph. This graph today. This one. How you will make the graph? Using Proteus. Here we have IC. In this segment we have VCE. Remember, IC and VCE. Okay? IC and VCE. And here you have what? Here you have different IB. IB, something like that. So, okay, let's make it. Okay? Let's make the graph. So how can you make the graph? Like this. Come here. We need the Proteus. Here is the Proteus. Okay. We need a transistor, NPN. Yeah, normal NPN device. That is generic NPN bipolar junction transistor. This one. NPN device, generic NPN bipolar transistor. I'm going to place it here. Then you might use transistor, but I'm not going to use transistor because what we need actually, we actually need what? We actually need VCE, IB and IC. These three things we have to calculate. So I'm going to need battery. This is enough. This is good. This is one battery. I need another battery here. Battery. I need a voltmeter. What is the voltmeter? From here, I will click the voltmeter. This is the voltmeter. Voltmeter is for VCE. I'm going to I'm going to measure the voltage to the collector to emitter. This is collector. This is emitter. So I'm going to measure the collector to emitter voltage. That's why. And I need IB. IB is this current. IB is this current, right? The current is flowing from here to here. This current is what? IB. So for measuring that, I need what? I need to cut it and use an ammeter. This is the ammeter. So ammeter must be microampere. IB must be in microampere. Okay. Oh my God. And I need to measure the IC as well. DC ammeter. Now IC should go like this. So this should be plus. This should be minus. Okay. So if you connect like this, it will give you a minus. So I'm going to do what? I'm going to rotate, not rotate, flip this. So the plus is here, minus is here. Now this should be in. Okay, this should be in milliampere. Okay. And this will be our ground. So you can see there is no transistor here. There is no resistor here. So that's okay, no problem. And we have to measure the voltage, and we have to record the thing. Record means we have to have some record. Okay, where we will keep our record? We will keep our record in the Excel. EXCEL, Excel. Okay, here. Now here, what you have to do? So what we will do? We will vary the IB, and we will see what is IC and what is VCE. That's it. So how can we vary the IC? We will change the battery. See here, they are saying max, 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 because the battery is bigger. So I'm going to change the battery voltage, let's say to 0.1 volt. We'll start from 0.1 volt. No, nothing, no current. Let's say, so for 0.1 volt, that means for zero, that is for IB, your VCE, not here. Let's check. See, let's make it also 0.1. That means zero actually. For zero, your voltage is zero, your currents are zero, right? Okay, wait a second. So okay, see, so what we will do, we will vary this battery and we will vary this battery and we will try to find some IB and IC. That's it, along with some voltages. So at first we will start from 0. Now normally the 0 battery is not possible. That's why 0.1. So for 0, your, okay, this is what? This is actually your VCE. This is your IC. And this is for IB, okay? Now, VCE is 0, so your IC is also 0, and for that your IB was also 0. Now, change this here. I'm going to change this. So if I give 1, see, nothing will happen. Because if it is 1, again your current is 0, your current is 0. For 1, current 0, current 0. Oh no. Okay. Do not write it here. That means this line is for when IB is equal to 0. Okay, this line when IB is equal to 0. That's fine. This line will be for when IB is equal to 10. Next line. When IB is equal to 20. This line will be when IB is equal to 30, like that. So you can actually go for like this. This one will be when IB is equal to 40. This one will be for when IB is equal to 50. This line will be for when IB is equal to 60. So actually you can make a lot of data and you can get it. At first we will do for when IB is equal to 0. Do not draw anything. Next, we will change the voltage to 5. Next, we will change the voltage to 10. Next, we will voltage for the 15. Next, voltage should be 20, like this. We do not need much more values, okay? This is enough. So for 5, if I increase the voltage to 5, do not draw anything. Okay. Here for 5, your input, your IB was 0 and your IC is also 0. So we can call it is 0. Again, I'm going to change these to 10. Here you can see it is still 10 volt, but no currents. So no currents. For 15, you will have the same thing. No currents. No currents. Why? Because remember alpha was, no, not alpha, sorry. Remember the beta was IC divided by IB. From here, can we write a formula like this? IC is equal to beta IB. Obviously, right? Obviously, you can write a formula. So from here, you can see this is the battery for IC, right? So if I increase this battery, the current should increase. But since your IB is 0, so what is happening? The value of beta may be 100. Your IB is 0. That's why your IC is eventually 0. So no matter what, how much you increase your battery, doesn't matter unless your IB is 0. If your IB is 0, your IC is also 0. So that's why IB is not increasing and IC is also not increasing. Because I am not increasing the IB, I am keeping the IB fixed. And I am checking the IC. Okay, now. Now next, IB is equal to 10. So what I'm going to do, I'm going to see by increasing these, let's say 0.7. No, not yet. One. Yeah, maximum. 0.75. 0.76. We increase slightly. 0.77. Almost 0.775. Yeah, 0.775. That is our voltage. Okay, 10 is enough. So this is our voltage, right? So this is our current actually. This is our current for 0.775. Our current is 10. So for 10 volt, okay, this is 10 volt. For 10 volt, our current is 1.03 milliampere. For 10 volt, our current is 1.03 milliampere. Let's change this value to 5 because we have a value for 5 volt as well. Again, same value, 1.03. Let's see the value for 1 volt. Again, 1.03. Let's see the value for 0.1. 0.99, but before that this current got increased. So this you have to adjust that. .74 maybe. .745 maybe. Yeah, okay. So now your current is for 0.1 volt. That means almost we can call it 0.1 volt for, that was 0.31. That means actually 0. We can call it 0. Okay, now. So for 15, so if I see the 15, if I increase the value to 15, because we have a value for 15, we have to take the value for 15. For 15, let's make it to 775. Your value is still 10 or 10.3, and your value is 1.05. 1.03 actually. Okay. For 20, you will still have your value 1.03. Okay, no change. Now for 20 microampere, so we need to readjust the battery so that you can get, what is that? 20 microampere here. So how can you do that? So okay, let's change the battery to 0.1. And increase the battery. Not increase, actually 77. 26, no, I need to make it 20 because this is for 20. So how can we make it 20? Maybe it's 76. No, it's maybe 765. 21, maybe 764. Yeah, that's okay. Or if you are very precise, you can call it 3.8, maybe 3.5. See the value, the battery. You can never get this value. You can never get this value in the lab. 0.7635, right? So that's why this is not a lab. This is not a lab or the experiment. You have to do it in the simulation. 20.4, no. Let's make it 3. Let's make it 2. Let's make it 0 actually. Yeah, okay. 0.763. That's 20.1. For 0, it will be obviously 0. For this one, it is 0.62 or 0.1 voltage actually. 0.1 voltage. Now you have to increase the voltage to 1. This voltage to 1. And it changes. So you have to readjust this again. No, much bigger. Make it smaller. 5. Make it smaller. 2. Almost. Okay, we can call it. We can call it 20. So now it is 20. So how much it is? 1.99. Okay. For next, if you increase the value here, if you make it 5 volt, you will see it is 1.99. Okay. Again, same. If you make it 10, you will see 1.99. If you make it 15, 1.99, something like that. So we can call it 1.99, 1.99, 1.99, 1.99. Okay. Next value will be this one for 30. So how can you do that? Change the value, not this. Change the value to, reset this value to 0.1 again. Now, come here. Oh, it is 61.5. No, we have to make it 30. So how can you do that? 0.78. So 38. We have to make it smaller again. So reduce the value. 7, 7, 8. 35. No. 774. 30.7. Okay, that's it. No problem. 70.4. That time your current. Current is how much? 0.95. Okay, this is also 0, obviously. Now change the value to 1. This value to 1. This will be changed, so you have to readjust. This has changed, so you have to readjust. At what? Let's say 8. No, we have to make it 7, 9. No, we have to make it 8. Almost 8.4. Okay, 8.2. No, 8.1. No, 8.05. Okay, 8.04 maybe. No. 803 maybe. Yeah, okay, 803. Now your current is how much for 1 volt? 3.04. So you can call it 3.04. Next one will be 3.04. Obviously 3.04, 3.04. If you do it, you can see it. Okay. So for next values, maybe for 60, we will check one. Or we will check one. For 0, it will be 0. Now for 0.1. No, it is too much. Too much. Too much. Not too much. You have to increase it to 9. 57 almost. So we can call it 791. Almost. $60.4. Okay, that's it. Now for point 1, your voltage is 1.87. Your current is 1.87. Now I'm going to change the voltage to 1 volt and see how much you got. You have to readjust this IB again. So obviously. .85. Too much. 0.82. Okay, almost.
Sir,
Yeah.
what could be IB 40 and 50?
No, you can do it by yourself. I'm not going to do it because they are actually the similar process, okay?
Okay.
So it's similar process, you can do it. You can do it by yourself, you can make all of it and you can do it. I want to check the last one, that's why. So you do it by yourself, okay, by same process. Got my point? So I'm going to upload the video just after the lab class and I will ask you to do one of it, okay? Do one and submit the graph to, maybe tomorrow. This will be one of your assignment, that's it. Maybe not tomorrow, maybe after 1 week, okay? You can do it, you can take 1 week of time.
Okay.
Okay? So, but just pay attention. If you are not understanding anything, no problem. You see the video and do it by yourself, you will understand. Change some values, adjust some. Okay, try to make it 10, try to make it 20, try to make it 30. Whenever it goes, whenever it was 20, but it become 30 sometimes for some reason, change the battery and make it 20 again. Got my point?
Yes, sir.
Okay. Now see. 61, no, I need to change it again. I need to reduce it, 0.5. Yeah, 60, now it is 60, no problem. Now, for 1 volt, your current is 5.99. Now, I'm going to change the battery to 5 volt. It's 5.99. I'm going to change the battery to 10 volt. $5.99. Okay. I'm going to change the battery to 15 volt. 5.99. So you can understand. So everything will be 5.99, right? So like this. So now I'm going to make the graph. So I do not need this anymore. I'm going to make the graph. How can I make the graph? Like this. So at first, I will click these and click these two. Only these two. One VCE, one IC. Not other IC. I'm going to click these two. I'm going to insert. Here, I'm going to come here and I will select these. Okay? Select this one. Or maybe this one. Or maybe this one. Got my point? I'm going to select this. Here, what I have to do, I have to add chart. I'm going to make it smaller. I'm going to click, right click and click edit data or select data. Here, select data. Select data will come up. Here I will just add graphs. How? So this series, I'm going to call this IB is equal to 0 microampere. You can see from here, IB was 0, right? IB was 0. That's why I'm going to call this series as IB is equal to 0 microampere. So, okay. Now I'm going to add series. So here, I'm going to click add. So series name will be IB is equal to 10, this one, for this one. So I'm going to click IB is equal to 10 microampere. So X value, which one is X value? I'm going to click this arrow. Can you see the arrow? Click this arrow and select the 0 to 20. Click enter. I'm going to select the Y value. Click these and select these Y. That's it. Okay. Now again add. The series name will be IB is equal to 20 for 20 now. Now your x value will be again the same VCE is your x value. What is your y value? Again, this is your y value, 20 for 21, okay? Now for next, add, series name will be IB is equal to 30. This name will be x will be this one, enter. Y will be this one, enter. Okay, add IB is equal to 40, 50, you do it. For x, this is your x value, enter. For y, this is your y value, enter. Okay. By the way, you can see some bouncy thing, right? It is bounce a bit. This is because of for less value. If you take more and more value, this will become smooth. So how can we make it smoother? We can make it smoother by changing the graph pattern. Chart type. You can come here and you can select these. Yeah, select this like this. Okay. So this is your graph. Now I want to make the graph a bit more beautiful. So how can I do that? Right click, move chart. Can you see the move chart? Move chart, new sheet, and write the. Okay, you do not have to write the name. New sheet. Okay. So a new sheet will come up. Here I want to highlight this number. So I will click the number. I will go home and I will change the, what is that? The font 18. I'll make them 18 as well. Okay. Now I want to write some name here, write some number here, write some number here. Oh, obviously I wanted it to come to 20, not 25. So right click, format axis. The highest value I'm going to set to 20. So this will be all 20. Now I need something more. I will go to design. I will pick quick format. Can you see quick format? So there I will select this. So here you have a chart title. Here you have some legend. Which color is which? You can see there. And here you have axis title. Now this axis title will be what? IC. In milliampere. Okay. This axis title will be what? VCE in volt. This one should be a bit bigger. 18. I can. This one should be a bit bigger. 18 volt. That's it. This one should be a bit bigger. 20 is enough. This one should be the output characteristics. What is the name of this characteristics? Not this. Characteristics. That means this is collector characteristics or output characteristics. You can call collector characteristics or output characteristics of a what? Silicon transistor. Okay? This is the characteristics curve, or you can just call it characteristics curve, no problem. Now every data I want to change the font. I want to change the font to Times New Roman. Everything is Times New Roman. Now this one should be 20 and bold. This one should be 18. Or 16 is enough. This one should be 16. This number should be again, since I changed the font, everything is changes. Okay. Now you can add some graph line here. How? Right click here, click this, right click, add measure grid line. You can add measure grid line, right click, add minor grid line. You can add some minor grid line. Here, click this, measure grid lines is already there. You can add minor grid line. So this is your graph. You can see all the lines. You can change the line width. Go to design, go to format actually. You can change the width as well to make it more stand out. more pop. This one you can make the weight like this, so that it is more understandable. You can even change the color. This color you can even change, not fill, outline. Okay, you can even change the color. This one, the lower one, you have, which should be this one, and the color, let's say your color is this one. Okay, got my point? So this is how you draw a graph. Understood, my dear?
Yes, sir.
Okay, this is the graph that we are seeing here. Obviously, this is for practical. This is the practical representation. So up to 10, 20, 30 is enough. But after that, you can see it is going up. It is going up, right? This is because of the practicality. For practical diode, it will go up, a bit up. But in theoretical diode or simulation diode, it will be like this. Okay? Okay?
Okay, sir.
Okay.
Okay, sir.
I do not need it anymore. Now, in the next class, I'm going to leave you today here. In the next class, we will do the next chapter, that is the bipolar junction BJT biasing, DC biasing, for DC biasing. So I have few videos. I already made few videos on that. You can go and look at those. Those are on English. So I'm going to click my channel or my videos. Here, I have few videos on that. Which one? Like electronics one, this one. So here, so this is a video. So I want you to see this video prior to my class, next class, okay? Here I made this video. I want you to see the video prior to my class, okay? Can you do that? Before my class, I want you to see this video before my next class. That means tomorrow, right?
Okay, sir. Yes.
So I'm going to, I'm going to give the link to you, and you see this video before coming to the class. Then we will start the class, because this is a very big topic. Very big topic. That's why I want you to know something, and I want you to be prepared for this. Okay?
Okay, sir.
Okay. So today I will finish here. Wait a minute. I'm going to stop the share. Today I will finish here, and if you have anything to say, okay, but before that, I have to take the attendance. Oh my God. I have to take the attendance. Wait a minute. Okay, 52 batch. Roll number 11, 18.
Yes, sir. 11.
Roll number 11. Okay, roll number 18, 19, 30, 46, 48, 49 is present, right? Roll number 11, 49 and 50, they are present, right?
Yeah, 50 is present.
Okay. Is there anyone else? What is Engineer Amir Odego? Engineer Amir. What is his role? 53 batch?
47.
He's 53 batch, right?
Yes.
Okay.
Brother.
على ورثة تزعل
Yeah.
ما أنت نقف كتوكم لنا يعني
Aniga waa iska dad badan iyo marba meelaan ka soo galay.
قد كانوا زاد وحنا والله عاد ما أنت ويجي ببحث ويسوق الجلان
Ina.
برو الدول
Okay, 53 batch. 53 batch. Roll number 4. Yes, he's present. Roll number 6. I do not know. Roll number 7 is present. Roll number 14.
It's not present, sir.
Then roll number 22.
Yes, sir.
Roll number 25.
It's absent.
26.
Absent.
Roll number 29.
Yes, sir.
Okay. Roll number 37.
Absent.
Okay. 43.
ما أنت وجود اللي كاس
Present. 43.
Yes.
وجود ما أنت اللي كاس
46.
70.
Absent.
Okay. 47. Present.
Yes, me.
Okay. 53.
Ra'ad Krino, present.
وراني 54 يعني
53 waa markii.
54. 54.
هو مقيم 54 yes sir
54. 55.
Yes, sir. 55.
Okay. Okay. Thank you.
Okay.
You can leave.
Saadaq معاه هذه afka ma ka xanuunsan